This second video on compound interest to accompany the book, The Financial Rules for New College Graduates, builds upon the first compound interest video in which we talked about the compound interest formula, which is FV, future value, is equal to PV, present value, multiplied by 1 plus yield, or Y, and raised to the power of time, or N. And that is programmed into this spreadsheet the following way. We start with, in plain language, $1,000. And we compound it at 7% for 10 years. And here is the formula, which I've highlighted in green, and I'll press so you can see the formula, which basically shows the cells in which we calculate $1,000 multiplied by 1 plus the yield raised to the power of 10. And the spreadsheet does a good job of showing us $1,967.15 would be the result of those assumptions. You can change any of these assumptions and see different results. You can see it updating, and that's a useful thing to have programmed. I want to show in this video why a spreadsheet has some advantages over just using a calculator or using an online calculator. You can design a spreadsheet that will tell you exactly what you need to know. So I'll just show an example of that might be better than just talking about it. Okay, let's say you are 25 years old. And you're contributing $1,000 to your IRA, but in fact, you're not just doing that, you're doing that for the next 10 years, or you're contemplating doing that for the next 10 years. We'd like to know how much will that be worth after 10 years if you do it for $1,000 for each of the next 10 years. So I want to set up a little table, and the table will be responsive to kind of what we want to see. So I would start here, and let's see, my goal is, I want to know how much this is worth in 35 years. When I am 35 years old, excuse me. In 10 years, when I am 35 years old. Starting out at 10 years. So I'm going to set up a spreadsheet to show me 10 years worth of compounding for that first amount. So I'm going to write in 10. Here, I'll just label this years. And I'm going to reference in this the amount that we're contributing. In this case, it's called PV. So I'm going to equal to $1,000. By programming it that way, I can change this number and it'll change my table. I'm going to build a little table right here, so you know where I'm going with it. Okay, now if you know a little bit about Excel, you might know that you can lock in a cell by adding little dollar signs here, and that way I can do an autofill function and it will reference the same cell. So now I have 10 $1,000 payments, and they each reference cell D3, as you can see, because I put in those little dollar signs. Okay, great. Now the reason I put in 10 here is because in the first year, when I am 25 years old, it will get 10 years worth of compounding. The next year, when I am 26 years old, that I contribute $1,000, that will get 9 years worth of compounding. And you probably know from Excel that I could do an autofill function and it will count down all the different years, 10 through 1. This is when I am, let's see if it actually fills in these for me. Oh yes, it does. So I contribute from between years 25 and 34, 10 years in a row, and this is the number of years of compounding. Now I want to calculate what is that going to be worth at a 7% return. And I put in the compound interest formula. So it's equal to present value, which I'll reference here, multiplied by, open parentheses, 1 plus yield, raised to the power of the number of compounding periods, which I have set up as 10. What that tells me is my first year's worth of, my contribution of $1,000 over 10 years will become that amount of money. Now I can once again lock in some cells so that I can do an autofill function, which I'm going to show you now, and find out what is the growth of all of my other payments over 10 years. Now I'm going to, that's interesting, and maybe we'll put in a total amount down here, which will sum up all of those amounts. That should become $14,783. Now, I want to sum up how much did I contribute over those 10 years. probably easy math, $10,000 are contributed, it became $14,000 at a 7% return. If I had a change in return, I can go, well, what if I got a great return of 10%? It grows to $17,000. What if I have a mild return of 5%? It grows to $13,000. You can already see why multiple payments can be calculated very easy by changing some of the terms. What if we do something different? Instead, we want to know what it would be like if I'm 65 years old. So 65, let me write that out so that we see what we're talking about. 65 years old. The longest payment you're going to let run for 40 years, and then after that, maybe 39 years, and after that. In this assumption, we're contributing from years 25 to 34, 10 years in a row, but it compounds for 40 years. The longest one compounds for 40 years down to 31. That result is different. We contributed $10,000, but at the end, once we were 65, it becomes worth $57,000. And if you set up your spreadsheet to do this for you, it's very simple to get simple results. What if, by contrast, I wanted to set up a slightly different scenario where I wanted to create a table of what if I got a 5-year return, a 5% return, a 7% return, or a 12% return. This is also pretty darn simple to set up. Let's see if I could just slide this over. Now this, I'm going to reference 7% return. I'm going to reference compounding for 40 years. I'm going to reference the original $1,000. I've switched over so that my cell of F8 will appropriately reflect $1,000 invested for 40 years at a 7% return. And that would become $14,000. Now that I've set these up, I can do an autofill function. And sum up these numbers. And if I can achieve a 7% return for between 31 and 40 years of compounding, that would be worth $112,000 based on my original $10,000 contribution. Finally, what if I could achieve 12% return? Again, I'm going to put in a present value formula. $1,000, multiply it by 1 plus yield, which is going to be 12%. I want to lock in that cell. Lock in that cell. Raise it to the power of 40 years of compounding. $1,000 becomes $93,050. And again, I'm going to sum that all up. And the lesson there is, if you were so fortunate as to make IRA contributions of up to $10,000, $1,000 each for 10 years in a row, if you could get a 12% return, that would be worth $588,849. In plain language, I think that's a very dramatic effect. The spreadsheet is, as this video is attempted to show, is merely a quick way to see that kind of analysis. Thanks for watching.